As it turns out, Python Pigmentize can only do so much for us as far as syntax highlighting goes, and we'll eventually have to do some post-processing modification on these generated files as well. And for that, we'll resort to Go as a programming language. So I'm going to run a go run command main Go, which we don't have that file yet. We are going to build it. And that command/main go will modify those HTML files and do some additional mutations on them and update those files as we see fit. And if it fails, we bail out from the script as usual. So let's start writing this Go file. So we'll create a command folder and add a main.go into it for starters. And since this is our main entry point, we'll have a main function here. Also, we'll have to name our package as main as well to make it a runnable file. Our program will do a bunch of things, but in essence, it will do a directory traversal, and for that, the Go standard library already has a utility method called filepath.walk, which takes a folder root and a walker function as its arguments. So I'll add some error checking here, and I'll also put these into their own packages to organize them better. So for that, I'll create an internal folder under our project root, which will logically isolate the project internal or protected resources that we don't want to publicly expose to other modules that might refer to this project. So that's kind of a, hey, this is internal, so if you don't know what you're doing, don't touch it kind of a convention that marks those files as project specific. And then I'm going to add an io.go and conf.go files into those packages. And we'll get our project root from an environment variable, and our io.walk function will be of type walkfunc. And walkfunc takes a path, a file info, and an error as input arguments and returns an error. So for now, I'll just return nil to make the compiler happy. We are going to implement this walker soon. And inside the function, if there's an error, we'll just return the error. And if our file doesn't need to be processed because maybe it's not the kind of file that we are looking for, then we'll return nil from the function and proceed with the next file. Otherwise, we are going to delegate our flow to a process function. And while at that, let us create a process.go file in this IO module as well, where we are going to put that process function into it as well. And our process function will take a file path to process and return an error in case it fails to process the file. So first we'll read the entire file into a byte array. And if there is an error, we'll just return the error. We'll first do some initial mutations on the file. And after that, what we'll do will be different based on the kind of file that we are dealing with. So if this file is a question file, we'll implement mutations specific to that kind of a file. Or if it's a source code file, which is the actual solution to the question, then we are going to do different kinds of mutations on that file as well. So by convention, our questions files end with duck.go.html, and any other file is practically a source code file for our purposes. So for question files, we'll use a function to do question-specific mutations, and for source code files, we'll use a different function to do source code-related mutations on them. Then we'll do one last round of common post mutations on the entire content, and after that, we'll convert the file content into a byte array and write onto this original file that we have been reading in the first place. And again, if there's an error, we'll return the error, and if everything is fine, we'll just return nil. So let's create placeholders for these missing functions as well. And actually, it's better to move these functions to their own related packages. So for that, I'll create a mutate.go under this IO folder, then cut and paste all these mutating functions that we write into this file. And I'll first start with mutate source code. And in all of these functions, the implementation details are not that much of an importance because what we do will be specific to what kind of HTML Pigments library has created before. So I'll just give this mutate source code as an example and skip the rest of the functions because essentially what they do are more or less similar. So what we do in this mutate source code function is we take our file content as an input, we do some regular expression replacement on it, and then return the updated file content as an output of this function. So on this particular case, we are injecting a toggle comments button whenever we see a pre-formatted text tag. All of the functions in this bundle will do more or less similar regular expression-based mutations on the HTML files. So with the magic of video editing, I'll fast forward the rest of the code creation process. And if you are interested, like I said, you can check out the source code files linked on this video's webpage to study separately at your own convenience. So okay, now all of our mutations are in place and it's time to test our generator script again. So I'm going to go and run hack generate sh and sit back and watch the generator work its magic essentially. And yay, everything is awesome. Or is it? Let's initialize an HTTP server inside this dist folder and check out the generated files ourselves. And it looks like our content is beautifully crafted, and the toggle commands button that we injected in the HTML to the top of the source code files works as well. It can toggle the comments on and off. So that part is done. What next? Next, we are going to create a web application that will eventually serve these files to the general public.